Hello, and welcome back. Today we're going to be taking a look at arrays. So arrays are nothing more than a collection of items. So if we think about arrays in the real world, some examples of arrays could be a light array, where you have a strip and you have a series of light bulbs that go onto it. Or another way to look at it is a bookshelf. A bookshelf has cubby holes that you can store books in. And so each one of those cubby holes could be thought of as an array, or as a placeholder for an array. So let's draw a little picture to see what an array might look like and how we're going to be drawing them. So what this is here is an array that holds 4 different items. And so each one of these can store some sort of value. You can also call them buckets, if we will. So in C++, the way in which you go ahead and define this or array of size 4 is like this. You do int myArray 4. And so what we have is we have the data type, and we have the identifier, or the name of the array, and then we have the size of the array. And you notice that the size is within 2 square brackets. So what this does is this tells the compiler that you're going to have an array that's going to hold 4 elements, and those elements are going to be of size int. So when we deal with data and accessing and setting data inside an array, in C++, we need to understand that all arrays are 0 based. And this is very important. So what this means is that when we start counting elements inside these buckets, that we start with 0. So this right here is the 0th element. This is the first. This is the second. And the last one is the third. So if the size is n, let's just call it n, the last element is always n minus 1. Okay, so the arrays get allocated in memory. Let's just take a look at that. So if we have memory, we just have a big block of memory right here. And we get an array. And you've defined an array that's going to be a size of 4. And so this array is actually going to be 16 bytes long. Or, yeah, 4 bytes, 16 bytes long. Each integer is 4 bytes. We have 4 elements, so we have 16 bytes of memory. So right here, we have a group of 16 bytes. So one important thing to note that in C++, when you declare an array, you just get the space for the array. Whatever values are held in memory right here, whatever values are here are going to be the values of those elements inside the array. So if you want to actually assign data to your array to get rid of those bogus data, what you do is you do myArray square bracket and then the index that you want to access. So if we wanted to set the first item to 1, for example, we would do this. And so our memory block would look like this. We'd have 1, and then I'm just going to leave them blank if they're actually an uninitialized value. And so this is actually true of all types in C++. I don't remember if we talked about it in the data types, but if you were to define just an integer, so if we had int x, and you did this, and you just did cout, you did cout x. If you did this, The value of x would be some random number. So just something to keep in mind that in C++, memory is always just assigned. It's never initialized for you. Okay, so here we go. We have my array 0. Let's say it my array. Let's set the last array to something, the last item in the array. We'll set it to -4. So now our array looks like this. We have -4 over here, and we have 1 there. Okay, so now one caveat that you are going to need to understand is that in C++, arrays are not bounds checked. And so what that means is when you write code like this, the C++ compiler is not going to tell you that what you have done is wrong. So even though we know that we've declared my array as a size of 4, the compiler is just doing basic mathematics to figure out the position of this value. Basically what it's doing is taking the my array and adding this number to get what spot it's supposed to be in. And so we'll talk a little bit more about that when we actually get to pointers, and yeah, you'll see what that makes, or what that actually means. So if we had our memory over here, this is what's going to happen. So we have our array that's allocated over here for us. So this is my array. And then we're going to go 10 spots off into nowhere, to no man's land, and we're going to write the value 2. And so this is going to happen. And so either one of two things is going to happen. One, you're going to get a crash, which is actually the best thing that can happen for us. Or two, or the second, you're going to get data corruption. So somewhere in your program, where a value used to be, there is now 2. And so this could lead to really subtle errors later on in your programs. So just be aware that C++ does not check your bounds for you. You need to do that. And so where we see this error a lot is in for loops. Or let's look at a for loop that somebody might write. So let's say we have an array. We're going to call it ARR. And we're going to have it a length 3. Okay, and then we're going to write a for loop. For int I equals 0, I is less than or equal to 3, I plus plus. Okay, and then we're going to set array of I equal to I. Oh, great. So what it's going to do is it's going to set our array into incrementing values. So in theory, we'll have our array, and it will have the values 1, 2, and 3. Well, that's great, except for this right here is less than or equal to. So what we're going to get, oh, sorry, this is going to work. So what we'll see is a lot of times is that people do this. Oh no, that was right. I was like, what? Sorry. Okay, so what we see is that we get less than or equal to 3. And so what happens is that when I equals 0, everything is happy because we get here. When I equals 2 or 1, we get here. Everything is happy. When I equals 2, everything is happy. But since we have a less than or equal to, I is going to equal 3. This condition is going to return true. And we're going to jump down in here, and we're going to try to write the value 3 here. This is why I got confused. This should actually be 1, 0, this should be 1, and this should be 2. Sorry, because I starts at 0. Remember, 0 based. So, Yeah, so what we're going to do is we're going to end up writing 3 into this random spot in memory. And so you'll see this check a lot. And so just be aware, be careful when you're doing your programming. If you ever get a crash, especially during debug mode, because it does some special stuff in the background and sometimes helps you catch these things a little better, always look to see that you're within the correct bounds of your array. And so now you might be wondering why we don't do bounds checking when we access data from our array, and the reason is performance. The C++ compiler and language decisions was around C++ being as fast as possible, and so there's no reason to check the bounds of your array if your programmer is doing the right thing and doing the due diligence to make sure that we're within the bounds. And so that's the reason why we don't have that. All right, so with that, we'll go ahead and call it wraps. Thanks.